All right. Good afternoon, folks. So, this is basic trig identities. The best way I can describe what these are, it's kind of like a puzzle, determining relationships between trig functions and using them to determine values. Okay. Later on, we'll get into something called trig identity proofs, proving that one identity determines or is equivalent to another function or identity. So what we're looking at today is just kind of getting used to the identities, the basic identities. I'm going to go over the reciprocal identities and the Pythagorean identities in this particular video. And I'm going to try my best to explain to you relationships of the identities. There's no, in a sense, right or wrong way about going about this, because ultimately you can prove an identity in multiple ways. And I think that's what sometimes makes this a little difficult, is the fact that, yeah, you can actually do this different ways and come out and arrive at the same answer. So, with that being said, you'll probably need a calculator. And the other skill that we're going to be using is rationalizing denominators. And if you don't remember how to do that, that's okay. I will kind of review that as I go through the work and show you where it'll happen and how to do it. So you have something called quotient identities, and then we have something called reciprocal identities. And I'm going to use these to figure out some values, okay? Excuse me. So here's basically how this works, and the best way I can describe what this does is this. You start off with a value secant of theta that is equal to a negative root 30 over 3. And you want to find the value of a cosine of theta. Okay. So what you do is you figure out what is the relationship between secant and cosine. Okay. So if I come up here and I look at this, I say, okay, I see that cosine is a reciprocal identity to 1 over secant. Okay. So if I wanted to find the value of cosine using this value, I could apply this reciprocal identity as 1 over secant. Okay. And the way that works is I take my value here, and I know that, and again, I'm going to write this over here, you can kind of see it, and I'm in a shadow for some kind of reason. But I do know that the cosine of theta is equal to 1 over secant theta. Okay. And that comes from this right here. So then I figure out, well, if I know that cosine of theta is equal to 1 over secant, and secant is this particular value, then I'm going to replace secant theta with the square root of 30 over 3. Okay. Kind of like that. Then what I know is the fact that a fraction within a fraction like this is going to cause me to do some reciprocal values. So this ultimately will become, 1 times 3 over the root 30 negative, which becomes 3 over root 30. Okay. That's what a reciprocal value that's what a reciprocal identity actually does. It kind of flips the values. Okay. So if you understand that, you could actually skip a lot of this mess and go straight to knowing that this reciprocal becomes this. Now, here's kind of the problem with that is the fact that you can't leave a root or a radical in the denominator value. So we have to rationalize it by multiplying root 30 to top and bottom. Okay. And when we do that, we get negative 3 root 30 over 30. So root 30 times root 30 is just going to be 30. And if you're not sure, use your calculator, plug it in. But then the rest of it becomes the fact that 3 over 30 is the same thing as 1 over 10, because you can divide both values by 3. And so your answer, or your final answer, essentially becomes the square negative root 30 over 10. So the cosine of theta is equal to negative root 30 over 10. Okay. The math itself is not, in my opinion, overly complex, but it's figuring out the relationships on things like this. Okay. So now if I look at the next one, again, I am given the tangent of x is root 2 over 4, and I'm giving the cosine as negative 2 root 2 over 3. I want to figure out the sine of x. Well, the sine of x, I'm going to come back up here real fast. Since I know I have tan, cosine, and sine, then I know my quotient identity right here is going to work with what I want, where the tangent is equal to the sine over the cosine. And it's just a matter of manipulating it to fit what I want. Well, I want it to be sine, okay? And so what happens is if I have tan theta, or tan x in this case, because we interchange those values, is equal to sine x over cosine x, then I know in order to get sine x by itself, or to figure out sine x itself, I'm going to multiply the tan x times the cosine of x is equal to the sine x. Kind of like that. Okay. So then I take my values. Well, the tangent of x, or tan of x, is root 2 over 4. So I'm going to take root 2 over 4, and I'm going to multiply that by the cosine, which I know is negative 2 root 2 over 3. And that's going to give me the sine of x. So I'm going to do a little bit of math. I know that this is going to end up being negative 2. Root 2 times root 2 is just 2 over 4 times 3, which is 12. That becomes a negative 4 over 12, which again reduces down to a negative 1/3. So the sine of x is equal to a negative 1 over 3. Okay. So next one, I'm going to look at this one. And I've actually worked this one ahead of time just to kind of see how I wanted to do this one, because there are two paths I could take to get this particular answer down. And I was trying to figure out the best way to approach it. And I think that's one of the biggest tricks on dealing with trig identities is figuring out what's the best path to follow to get to what you want. Okay. So here's what I kind of worked through and what kind of figured out. Since I know I had cosecant, since I know I have cotangent, and I'm looking for secant, I know cosecant works in conjunction with sine. I know cotangent works in conjunction with tangent, and then I know secant works in conjunction with cosine. And knowing that much, I can probably figure out that if I want to figure out cosine using a sine and a tangent, I can come back to my quotients and use this particular one here. And I'm going to have to work some magic here to get what I want. But I also know this, because cosecant and sine are reciprocals of each other, okay, and cotangent and tangent are reciprocals of each other, then I can work this a little bit to the fact that secant is reciprocal of cosine also, right here, okay? And that's actually how I'm going to work this. I think that was the easiest path I found when going through this. So if I wanted to do, I'm going to do a little bit of work here. But I do know that cosecant and sine is 1 over cosecant. Sorry. Which means that if I take the reciprocal of 7/3, then sine will be equal to 3 over 7, because that's the reciprocal of cosecant. Okay. I know tangent and cotangent are reciprocals of each other. So if I want, and again, that's tan is equal to 1 over cotangent. So then I can take that the tangent is equal to the reciprocal, which would be negative 3 over 2 root 10. Now, I'm not going to rationalize this denominator yet because I'm not quite done with what I want. Okay. So now the rest of it is this. I need to figure out what cosine is first in order to do the secant. So cosine, here's your tangent, sine, and cosine. Cosine is going to be equal to sine over tangent. And again, it's a little bit of practice. Get used to that. I know that. But the cosine is equal to the sine over the tangent. I know the sine and the tangent because I just kind of did those here. And so if I plug those in, so that cosine is equal to 3 over 7 all over negative 3 over 2 root 10. And I'm getting a shine on my paper. I apologize for that. I wish it was a little bit cleaner. It's not. But I'm going to essentially multiply 3 over 7 times 2 root 10 over negative 3. Now, that's the reason why I didn't rationalize it, knowing that this was going to happen. Now, again, I know this, and I know that, y'all will figure this out too. But here's what happens. And here's kind of why I like doing it this way, or why I think this was the easier path of the two. Focus. There you go. This 3 and this 3 will actually become 1s because they will divide each other out, which makes my work a little bit easier because now that gives me 2 root 10 over a negative 7. Okay. Now here's where I'm going to finish this off because I need the secant of b, beta, whatever you want to call it, which is the reciprocal of cosine. 1 over cosine. I just found cosine. This is cosine right here, by the way. So then I can reciprocal this to where it's negative 7 over 2 root 10. Rationalize my denominator by multiplying by 10, top and bottom. So I get negative 7 root 10 over 20. And the reason why it's 20 is because root 10 times root 10 is just 10, times 2 becomes 20. So secant, and this is, I probably could have done this with a little bit more paper, I'll be honest with you. But that's a kind of problem where I could have done this multitude of ways. I actually found a different way of doing it also. But that was, the other way was kind of a little bit longer to do it. And in case you're wondering what I did, my step 1, this was step 1, this was step 2, so you know what I did. Step 3 was to do the cosine, sine over tan. And then step 4 ended up being to take the reciprocal of the cosine to get that value. It's not a very good camera to begin with. Sorry, it's kind of what I have to work with right now. So there it is. Move it up to maybe get a little bit better picture. Yeah, that's a better picture right there. Look at that. It's this shine. I don't know where the shine. Gotta fix that. Okay. So those are quotient and reciprocal identities, and that's kind of how you use them. I will post some additional examples so you can kind of see them, but that's in a nutshell what you want to be doing with these. The next thing I'm going to talk about are Pythagorean identities. And the reason why they're called Pythagorean identities is because they look a lot like the Pythagorean theorem. Okay. So the way these work is, yes, you're going to be scoring some values, so you definitely need a calculator for this. I want to find the cosine of theta and the sine of theta, tangent of theta, knowing that I have the sine of theta of negative 1/3. And I also want to make sure that my answer is less than going to be 0 for the cotangent. Okay. And I'll get to that here in a second, what that actually means. But first thing is, I'm going to find the cosine of theta because I have this cosine squared plus sine squared is equal to 1. I know my sine. I can find cosine using this guy right here. And here's how that works. Okay. It'll be cosine squared of theta plus sine squared of theta is equal to 1. My cosine squared plus, and again, my sine is negative 1/3 now. So negative 1/3 squared is equal to 1. So my cosine squared of theta is equal to 1 minus 1/9. And I've got to remember to use extra paper on these because I'm running out of room. It goes to 8/9. Then I square root so that the cosine of theta is equal to the square root of 8 over 3, which if we're going to simplify square root of 8 down, becomes square root of 8, just so we can show, basically becomes square root of 8 becomes square root of 4 times square root of 2. So that's 2 root 2. That's simplifying a radical value. So that's going to essentially become 2 root 2 over 3. So the cosine of theta is 2 root 2 over 3. Plus or minus. I always forget that part because I square rooted a value. Okay. Since I don't know which one it's asking for, I'm going to leave it at that right there, plus or minus 2 root 2 over 3. Then I'm going to find the cotangent of theta. Since I have, I'm sorry, not cotangent, since I have the tangent of theta, I'm sorry, I have the cotangent of theta, I want to find the tangent of theta, where my cotangent is less than 0. So my cotangent of theta basically looks like this. Since I know that the tangent is 1 over cotangent, okay. So in order to find the cotangent, let me see what I do have to work with here. I know the cosine. I can find secant squared by doing a reciprocal of this. That's what I'm going to end up having to do this. Okay. And I'm gonna throw some paper on here too, because I'm gonna run out of space if I don't. And I do apologize for having such small spaces. But here's basically what I'm gonna end up doing. You can kind of see it. All right, so I know the cosine. I can find the tangent of theta this way. Since I can find secant, since cosine, so secant is equal to 1 over cosine. Okay. So my secant is going to be equal to 3 over 2 root 2. That's my reciprocal, since that was cosine. Then I'm going to use this along with my tangent square plus 1 to figure out tangent square. Okay. So it's going to become tangent squared theta plus 1 is equal to secant squared theta. Okay. So here we go. Tangent squared theta is equal to, sorry, let me do this again. 3 over 2 root 2 squared, and there's a reason why I didn't rationalize it yet, minus 1, because I'm going to essentially subtract 1 on both sides, like that. So that gives me the tangent of theta, which is equal to 9 over 4. And again, if you're not sure, 3 squared is 9. 2 squared is, oh, no, this is not 9 over 4. This is 9 over 8. So 2 squared is 4 times 2 is going to be 8 minus 1. Okay. Let me just show you what I did real quick. So 3 over 2 root 2 squared. 3 squared is 9. 2 squared is 4 times root 2 squared is just 2, which is where the 9 over 8 comes from. Okay. So then I get 9 over 8 minus that. That's going to essentially be 1 over 8. So the tangent squared theta is equal to 1 over 8. Square root. And I get that the tangent of theta is equal to 1 over the square root of 8 plus or minus, which is going to become 1 over plus or minus 2 root 2. And again, because the square root of 8, which I did earlier, is the square root of 4 times the square root of 2, which becomes 2 root 2. Okay, I'm doing all my scratch work on this side, in case you wonder what I'm doing. So here's what I need. I need the cotangent of theta. Cotangent is equal to 1 over tangent. So that's going to essentially become the reciprocal of this value. And because I want it to be where the cotangent of theta was less than 0, I only want the negative value of this, because that'll be less than 0. Okay. So that's going to become a negative 2 root 2 over 1 to do the reciprocal. That's a lot. That's a lot of, yeah, that's how you do it though. Okay. So cotangent theta, where it's less than 0, is equal to negative 2 root 2. Okay. So definitely have extra paper on you because that took a lot longer, a lot more paper than it did the first time through. Yeah, that's that. So that's that, and so the cotangent. Sorry, that's cosine. The cotangent where theta is less than 0 is equal to negative root 2 over 2. Okay. These take a little bit of practice. I get that. So don't try to rush it through if it's not working out right away. Okay. All right. Next one. Tangent of x and the sine of x. You're looking for, let's see, we have the secant and we have the sine. We want the sine of x where it's greater than 0. All right. So secant, first of all, is going to be, where is, I don't need that paper right now. Secant is the same thing as 1 over cosine. Okay. I can use that to find cosine. I know tangent, and I can use my quotients to figure that out. So that's kind of nice. And I want the sine of x that is greater than 0 as well. So let's do the first part first. Okay. So secant, I know it's going to be, let me reverse this, where I'm going to use that the tangent is sine over cosine. Okay. Oh, and if I get the sine of x, yeah, let's see, do I want to do it that way? Yeah. So then I'm just trying to see if there's a different way of doing this with the Pythagorean. And there is. Yeah, let me do Pythagorean instead, since this whole thing's about Pythagorean, because I need a certain value with this guy right here, so I've got to have certain numbers to do this. All right, so right here, I'm going to use this guy right here. Secant squared minus 1 gives me a tangent squared first. So tangent squared and is equal to the secant squared is minus 1. So that's what I'm going to do first. I'm going to do it that way. And again, remember what I said earlier? There are different ways of doing things. It's just a matter of what am I trying to find out. And since I have this guy right here, I need to do it this way. Okay. So tangent squared theta, or x, I keep using theta and x differently, interchangeable, becomes 6 over 5 squared minus 1. So the tangent squared of theta is equal to 36 over 25 minus 1, which is going to be, this is going to be ugly. 36 minus 25 is 11, I believe. This is taking longer than I thought. 11 over 25, square root. So the tangent of theta, or x, is going to be essentially the square root of 11 over 5. Okay, so there's that first part. Then I want to find the sine where my value of x is greater than 0. So now I'm going to go ahead and use my, this is plus or minus, sorry. I always forget to do my plus or minus for square roots. Because I need to make sure that my value is greater than 0 when I'm all said and done. So if I do, let me pause it here for 1 second. I hear something going on. All right, so I just wanted to be sure how I wanted to approach this, the easiest way to do this. And the easiest way to do this, what essentially is going to be to use tangent of theta is equal to sine over cosine. Okay. And so what happens is this becomes the tangent of theta. And again, I know it says x here. I'm used to using theta just out of my own. Gives me my sine theta. And the answer I'm going to get using this is going to have to be greater than 0. So right here, when I have the plus and minus, I want to make sure I use the positive part of this. So square root of 11 over 5 times my cosine. Cosine, this is secant. Cosine is a reciprocal of that, which is going to be 5 over 6. So that's going to give me root 11. Make sure I did that right. Yeah, root 11 over 6 for sine of theta, which is greater than 0. So I just wanted to be sure that that was going to happen the way I did this. So there you have it. So those are your quotient and Pythagorean and reciprocal identities at work. I'm going to post some more examples for you to kind of look at, already worked out, and kind of see how I did them. So, there it is. And my suggestion would be to keep a chart like this by you. If I can find mine that's not as busy, then I'll post one up also for you. But that's, those are your quotient reciprocal identities, and then those are your trig identities. I always say if you have note cards, that's a good way to keep them with you, is to write these on note cards. Put these on one note card, put these on one note card, put these on one note card, and that way you have them with you when you go through values. Because we're starting this new. We haven't gotten to these yet, which these are actually as bad as they look, so that you know. But we haven't even gotten to the proofs yet, and the proofs, require you to really think about proving that certain things actually exist. So, all right, folks. Well, there you have it, and we'll see you around.